Greetings of the day. Our final year project title is a hybrid large language model for drug discovery using quantum machine learning. To begin with, we have so many diseases in the world right now, and especially in the case of rare diseases, they are quite difficult to cure. This is because the entire process of drug discovery, starting from finding the drug to testing and validating it before applying it to humans, is actually time consuming and quite complex. So people try to incorporate AI or ML techniques in it, but then the process became computation heavy. In order to combat all of these set challenges, we have decided to use LLM with QML because large language models, they are widely known for extracting structured content from sources like papers or articles, while quantum machine learning can be used to handle complexity in various models. Our final year project title, it comes under the Sustainable Development Goal number 3, which is good health and well-being, while it can also be linked to goal number 9 and 17, which is innovation, infrastructure and industry and partnership with goals. Now here is a live demo of our website. Our backend has been deployed in Hugging Face spaces, while our front end is in localhost for now. The scientists or the authorities, they can log in using their own institutional email and the corresponding code that comes along with it, so that we can ensure that only authorized people are using this website. And in this we have two main modules, which is the LLM module and the QML. For the LLM module, we have used BioGPT and we have fine-tuned it according to our own dataset so that we'll be able to use it for our own needs. And in this case, first the user will be able to input the name of the disease, upon which NER will be performed, which stands for named entity recognition. And in this, the name of the disease and the target, they are extracted from it, so that we'll be able to perform ontology mapping on them and the relationship between them is extracted. Now using this, we'll be able to identify the target, or in this case it will be a protein, and based on this the target will be used so that we'll be able to generate an entirely new drug, so that we can pass it on to the next module as a series of list. And here we also have the feature so that the scientists or the authorities, they can change the number of the candidate molecules that are passed on to the next module as well. Now onto the QML module. First we have used variational quantum classifier so that we'll be able to classify the generated molecules based on their drug feasibility, or in other words the chemical feasibility. And using this, the final score is also given, and from there we also have multiple features which can be accessed if the score is particularly high. First we have the ADMET dashboard, where we have the ADMET scores given for each and every single feature. And ADMET stands for absorption, distribution, metabolism, excretion and toxicity. Now the values for these 5, they are given and evaluated, and correspondingly we have the Lipinski rule of 5 as well, so that we can give the scientists another holistic view to help them to understand how this drug or how this molecule works in the case of the human body. And we also have GI absorption, or in the case of liver absorption we have CYP, and even the toxicity value is also given, so that the scientists, they'll be able to see which particular functional group or atom contributes the most to its toxicity. Now within this feature we also have XAI or explainable AI, and in this case we have used kernel SHAP analysis. First of all, the explanation for this particular score and which atom or a combination of atoms contributed to this score is also given, so that the scientists, they can modify it in the next feature. We also have descriptors which is an overview of all of the Lipinski rule of 5. Then we have the Morgan fingerprint so that we'll be able to represent them in a standard way. And finally, we have the explanation part where it will tell you about the score and how it differs or varies from the baseline score, which is the average score of the model. Now coming back to the ADMET dashboard, the users, they can download this report as a PDF, or they can also download the 2D molecular image as well if they would require to do so. The next feature is virtual reality. In this we have three main modes. The first one is ball and stick, where the users will be able to see both the atoms and the bonds. In the next mode, which is the space fill, they'll only be able to see the atoms, while in the last mode, which is sticks, they'll only be able to see the bonds. Now, the main primary feature of this virtual reality is to enable the user so that they can modify the chemical molecule according to their needs. For example, if they would want to add an extra atom or an entire functional group to it, then they can do so by clicking on the particular atom or its bond and adding whatever atoms that are given as input for them. Now, if they would also want to remove the atom or the functional group, then they can again do so using the remove feature. And finally, the score of the QML will also be updated based on the atoms that have been added or removed. This is to ensure that the scientists or the users, they can speed up the entire process of de novo drug generation and possibly reduce the complexity of it as well. Now in the next feature, we have lab synthesis route. First of all, this feature is used so that we'll be able to tell the users how they can create this particularly generated molecule. The step-by-step procedure is given and the corresponding ingredients, or in this case the reagents, they are also given so that they can procure it before they come for this creation process. And finally, we also have the safety measures so that we can provide some form of safety from the users and scientists' point of view. Now in this feature, we have also incorporated a hardware module so that the users will be able to see how the current lab setting will affect the creation of the generated molecule. We have used DHT sensors and BMP so that we will be able to get the temperature, humidity and pressure of that particular lab setting. Now based on this, a final output will be given which will tell the users whether the current lab environment is suitable for the creation of that molecule. Now for the final feature, we have the rank by symptom feature. In this, if the name of the disease is not quite known or only the symptoms can be identified, then these symptoms can be given as input, based on which the QML weights can be changed as, for example, either 50-50 or 60-40 and so on. And based on this relevance that has been given and the QML weights, the final score is also changed so that the users or the scientists, they can see how a particular symptom, for example arthritis or any kind of pain in the bones, will affect the molecule, or how the molecule will in turn affect these kind of symptoms. Now back to our home page. Here we have the architecture diagram where, as stated before, we have two main modules and the description of this diagram is also presented over here. And then we have the flow of this system where the first flow starts from the input of the disease and the LLM will be able to extract the target and the name of the disease. Based on that, the molecule will be generated, and then in the QML module it will be converted to qubits so that it can be classified, and finally the druggability score of both the LLM and the QML is combined, and the ranked outputs are then presented using multiple features to the users as well. And then these are the technologies which we have used, and from this we also have the feedback loop, where based on the QML score which will be updated whenever the generated molecule is updated, then the corresponding features, for example the VR feature or the ADMET dashboard feature, they will also be consequently updated. And finally, we have the rare disease page, where we have a list of diseases which the scientists or the users they can use if they might want to refer to it. And we also have a search pattern here for their ease. So this is our entire hybrid framework using LLM and QML for drug discovery, where we hope to speed up the process, especially in the case of rare diseases. Thank you.